I think, yeah. I think I'll go through and I'll go through the steps of this and then I'll give you guys some time to do the second one. Okay. For those of you who don't remember long division. Now, some of y'all teachers might have done it differently than I'm doing it. Actually, I know for a fact that the kids in like probably starting about 6th grade, they don't do long division like this. They're teaching it differently now. They do it with units and things. There's a remainder. I don't want you to do decimals though. I'll show you how I want you to write the remainder. Okay. So 12 is a 2-digit number. So when I go to divide, I look at 2 digits of the dividend, and I think, and you're welcome to have the calculator out. The process is important because your calculator will not do it if there's variables in here. So you have to know the process. 12 times 6, well, 6 times 10 is 60. 6 times 2 is 12. 16 and 12 is 72. So I'm going to go with 6. I'll write a 6 at the top, and then I multiply. And I get 72, and then we subtract. 4, and 12 doesn't go into 4. What do we need to do?
You gotta carry the 0.
Bring that 0 down. Start the whole process over. I know 12 times 4 is 48. That's too big. So maybe I'll do 3. 12 times 3 is 36. 3 times 12 is 36. Subtract down. That's 4. 12 doesn't go into 4, so I'll have to bring down the 3. I'm going to go 3 again. I got a 7. I got a 7. Remainder 7. Now, when you first use remainders, we did a capital R to say a remainder. And then more advanced, your teachers had you doing 0.0 and you were bringing out zeros and making decimals. I don't really want to do decimals because at some point you just stop, right? When really you can keep going. So instead, I'm going to write the remainder as a fraction. What we have left here is 7/12. So this is 633 and 7/12 left over. Okay, I'm going to wait and give you some time to recall that. I've been thinking about 25 this whole time because 25 goes into 100 4 times, so that's gonna help me. So this is 130, so this must be 5 times. So I'm gonna go with 5. 5 times 4 is 20. 5 times 2 is 10. Plus 2 is 12. Subtract down 10. 24 can't go into 10, so I bring my 3 into it. 8, so 24 times 4. 4 times 4 is 16. 4 times 2 is 8, 9. You can use a calculator for that multiplication if you want. 7. Bring down the 2. That's 3. 3 times 4 is 12. 3 times. Oh my gosh. Remainder 0. Remainder 0 is a big deal. It's such a big deal. I'm going to use my time and energy to write a sentence about it. Remainder 0 means, Libby, what do you think? You got it? You got it? 24 can go into 13. You guys, because 24 goes into 13,032 evenly, remainder 0, that means we found ourselves a factor. That's a really big deal in the world of factoring. If we had a factor with this 13,000 number, we probably wouldn't know much about it, but we just found a number that does divide into it, 24. So as we move forward into polynomial long division, one of our goals will be to find remainder 0 because that's going to help us find factors. So remainder 0 is really important and special. Other remainders are significant too, but they're not factors. And factors help us find zeros, which help us make graphs. So, all right, you guys, get out your work from yesterday. I'm going to give you a chance just one more time to check answers. I'm going to come around and see how many you got done. Yep, the worksheet. Just whatever you did in class.
That's a problem.
I think it's right. Yeah. I got done. Okay, wait. I'm not. You're welcome. For anything. Anytime.
Here's the first six answers. Was anybody absent yesterday? The answers are on Schoology.
Yes, you did. He really said it.
Alright, so this is posted. So if you know you need more practice, just so you know, these problems are going to be there. They're going to stay there as well as the answers. The answers and the problems are in Schoology. Here's the end. Maybe you didn't get to the end. You're thinking, well, you really could have done more with that multiplication. I'm going to show you really good. Good job. Okay. All right. All right. Yeah, it looks like a lot of us didn't get some multiplication, so you know there's extra multiplication practice here if you go further. Since today we're starting division and all. You want to show me No, actually, they're before that. Actually, Cadence, did you want to show me Monday? You can. You Okay. Here's 14, 15, 16. Wait, who's going to start it? No, you Alright, do you want to talk about, let's come up for a moment. I just want to make sure that you're understanding of the difference between a quadratic and a cubic is there. So, for instance, if you are working with the area of a rectangle or a square or any two-dimensional figure, that's length times width. So that area would be x squared, right? And this is talking about the volume of a pool, I believe. So as soon as you go from area to volume, you introduce a third dimension in. So that means there's a third, and that's why we get then to x to the third. So as we move to higher degree polynomials, know that we're thinking about more dimensions, really. So like Amazon, is like crazy efficient. That's their business model that's made them so successful. Their factory has this like conveyor belt, and every product has like a volume and dimensions, and then it just shoots left or right to the different size boxes. Have you guys ever got a little product in a huge box from Amazon yet? Yeah, they're starting to not care. They're just like, whatever's gonna make this quicker. But their programming, their software is doing cubic polynomials because it's a volume. Okay, so the programmers who are figuring out the volume of a product and which box will it fit in, that's all some sort of an x to the third polynomial. Yeah. Yes. Yep. Like that. And that would make this fourth degree ultimately. That's correct. Good one. Good observation. Who else has something to say about these? Alrighty, alright, so let's move into division. I think we're going to page 332. That looks good. I was introduced to this acronym last year. There's another one that's better, but no one's reminding me this year. The long division acronym, I don't know if any of you ever heard this, but it goes divide, multiply, subtract, bring down. Someone said it's, does McDonald's sell burgers? They do, yeah. They do. DMSV. anyway, I'm really not too concerned about that, but I'm gonna highlight what's important here. Hector, will you please read what I've highlighted in yellow? Okay, this is a really big deal. This is gonna make or break you, so you have to write this down. This whole slide doesn't really matter. Here, this bit that I'm scribbling around, that really, really matters. This is brand new to you, you've never done before. The thing about polynomials that makes them different from just numbers. Well, if a number doesn't have like a digit, there's a 0 there, right? Like we couldn't just say this is 763, but there are 0 tens in this number. When it comes to polynomials, they can start with a 4th degree polynomial, and then it goes to a 3rd degree polynomial. But then if there isn't x squared or x to the first or any exponents, when you subtract down in long division, the whole thing gets messed up. The units don't align. So you have to insert zeros. So this goes degree 4, degree 3, degree 1. The 2 isn't there. So you must rewrite it with 0x squared. If you don't do that, the process flops. It's no good. Ready to hear it again? This is the problem here. It's x to the 4th, x to the 3rd, and then it skips to x to the 1st. There's no x squared. Just fine, no big deal. But long division won't work if you don't have something there. So you put a little placeholder in, you put a 0 with it. So when you look at your exponents, they have to descend. 5, 4, 3, 2, 1, 4, 3, 2, 1. You can't skip any exponents. Because when you line it up, it won't line up right. All right, we're going to look at your resource, page 332. I'm going to tell you what the book shows well, and I'm going to tell you some things they didn't really show well. You guys ready for 332? Can I stay? Oh, wait a minute. You don't have to do it anymore, okay? 332. All right, page 332. Of course, it's blurry. Okay. Long division of polynomials. When you divide a polynomial f by a non-zero polynomial divisor, you get a quotient. So this looks like f divided by d is q, q for quotient, and a remainder. Notice that the remainder is called r. It's set up like a fraction. Our remainders today will be written like fractions. The degree of the divisor is less than or equal to the degree of the dividend. That has to be true. The degree of the remainder is less than the degree of the divisor. When the remainder is 0, the divisor divides evenly into the dividend. One way to divide polynomials is called polynomial long division. All right, right off the bat, I see this is the same problem I just wrote out. Look at, they put a 0x squared in. It wasn't given. They put it in there. So you can circle that because you'll forget it. We talk about it a lot, and it's still, I mean, sometimes I forget it still, and I've done it probably 1,000 times, and I still forget 0 sometimes, so you're going to forget it. Okay. So what are we doing here? You're going to focus on x squared. You can ignore these two things for a while. So all of your attention is on what's out in front. We're going to focus on x squared and 2x to the fourth. You're going to think, what would make x squared match the first term? Match 2x to the fourth. What would you multiply in? X squared times what would be 2x to the fourth? You'd have to multiply it by 2x squared. You figure that out and you write it up top. Then you distribute.
Wait, what?
I'm going to do 2x squared times x squared, put it here. I do 2x squared times 3x, I put it here. I do 2x squared times 2, and I put it here. Distribute down. It'll take like maybe 4 full problems before you get it. Okay, so no one's expecting you to read this by yourself right now and understand it, just so you know. It'll take a good 20 minutes before it clicks. That's okay, I'm just starting. I do have a question for you. So these two are supposed to cancel out, but how did they go from positive 3, positive 6, to negative 3? It is subtraction. And they state subtraction here, but they're not showing. So go ahead and write it in. In division, you subtract down. So I put a subtraction sign in parentheses. What's happening here is they're subtracting. So 2x to the fourth minus 2x to the fourth, that cancels. 3 minus 6 is negative 3. 0 minus 4 is negative 4. And the 5x has been brought down. Yes. Distribute it.
So, wait, so what number will be the next number you multiply?
Well, we're going to go back. You start the whole process over. We'll focus on this negative 3. How do you make x squared look like negative 3x squared? You multiply it by negative 3. Mabry, what's your question? I use it in the subtraction only. Now I distribute again. I write down the product here. Negative 3 times 3 is negative 9. Negative 3 times 2 is negative 6. Subtract down. Rocco, did you have a question? Libby, did you have a question? Yes, that's a good one. This first thing should always cancel, or you picked the wrong number up top. The purpose is to do this minus this, and it cancels. Like 7 minus 7, 0. All right, so, man, really, is this 5? Are you guys buying into this 5 here? How did they get 5? What's this 5? Remember, when you subtract a negative, that becomes addition. So this is actually negative 4 plus 9. Remember, minus a negative means add. So negative 4 minus a negative 9 is really adding. They got the positive 5. Wrote down the 1. You think you start the whole process over. X squared into 5x squared. What do I multiply x squared by to make it look like 5x squared? 5. So there's a 5 up top. And you distribute. And then, so we do it all over again. Line it up, subtract. Now, as soon as you're here, when your number here, your x, has a lower exponent than your divisor, you're done. That's a remainder. I will say that this is a very long question. All of your problems today are shorter than this. So it's good the book provided you a very long one, but this is as long as these get. I don't ever give you a problem higher than, I think there's maybe one x to the fifth, but this is a long one, okay? Now we need to see, how did they show the remainder? This is, I'm going to box answer. This is the answer, okay, down here. This came from the top, whatever is written on top of the long division bar. 5x squared and 5x squared?
No, like in the box you just did.
This guy?
No, but the box you just made.
Yeah.
Where did the x go?
Why would there be an x there? There's no x there.
Because I'm confused. How did they get that? Like,
It's already x squared, and you're trying to make it look like 5x squared. You just need a 5.
no, because in the original problem, it's x right.
Yeah, the original is under, that's here.
Oh, never mind. I forgot.
Alright, so that's the remainder over the original divisor. So remainders are written like fractions. Yes. That's the real challenge in figuring out. Let's look at one now that's not done and try to figure out where is those top numbers coming from. So we're going to turn the page and we're going to do 2 problems on the next page. And let's talk about the top. I'm just going to rewrite mine because it's blurry. Yes, Peyton. The answer? Yeah. Okay. So the top comes right away. Right away, we got to pick a number for the top. We're going to focus all of our attention here. Ignore the -3. Who cares about the -3? The -3 works itself out. Focus on x. To get the numbers up top. This is page 333. We're doing number 1 and 2. It'd be 2x. So you're thinking, how do I take this x? And how do I make it look just like this? Because my goal is for them to cancel. So I need that exact number. Well, x times 2x is 2x squared. So up top, I'm going to write 2x. Because you have to think, how do I make this look exactly like this? Well, x times 2 and one more x. Okay, next. Brandon, what do I do next? You do know, think about it. What do I do next? Not ready for that yet. What do I do next? Distribute. Distribute down. I'll do 2x times x is 2x squared. 2x times -3, -6x. And in McDonald's, does McDonald's sell burger? We're on the subtraction part. Does McDonald's sell burger? Subtract. What is -5 minus -6? That's a 1x. Good job. That's why you guys are here. We don't do that right now. Number 1. -5 minus the -6 is just x by itself. Minus a negative becomes addition. 2x squared minus 2x squared cancels. Bring down a minus 3. Now, how do I turn x into x? What do I need to multiply it by? It's already x, so I put a 1 up top. Yeah. You need this number to perfectly match this number. Right, so that's why we just picked 1 up there. It's not negative 5x anymore. Because we've multiplied through, it's now an x. You know what you should do is just start trusting the process I'm telling you, and then go back and ask that question. So just don't dwell on that. Yep. All right. There's some of you are getting it, some of you aren't. If you're getting it, move forward. If you're not, keep asking questions. You're asking me about this green one? That is negative 5 minus negative 6. These two cancel and become a plus. It's negative 5 plus 6. Alright, so I got a remainder 0. You guys stop your side conversations. Dominic, you stop. Everybody over here, you stop. The cool thing about a remainder 0 is that our answer, 2x plus 1, that quotient, means we have factored. Some people, in the grand scheme of things, actually like long division better than the A times C method. Right now, if we did the A times C method to what's under this bar, our factors would be x minus 3 and 2x plus 1. So we found the factor without having to do the A times C method. Every time you find remainder 0, you've actually gone through the process of factoring in a different way. So this can be really useful. All right, let's try number 2. We're done. Yep. More or less, yeah. It's really just the first one. So, Anna, when I was doing 12 into 76, you weren't saying, well, what about the 3? What about the 3? I said, you know what? That 3 will work itself out. Okay? When I did 24 to 130, you didn't care about that too. You didn't care about that too. Alright, Mary, what's our first number here? We're named Alright, I'm away.
Separate sheet of paper for this.
Okay. Last one. Oh, it'd be minus 5. Minus 5. Yeah, because of that. Yeah, I know. Are you just okay?
What's x squared times that?
Is there a remainder in this problem? I'm not seeing it. Wait, let me see. Oh. It's you put X on top. X times X. No, it's X.
Not yet, not yet. All right, does anybody have a question about why I picked 4?
When I did all the steps, I got a 8. Where you put the 11 at? It's wrong because she's she looks like that. I have to try and get it. So, and then I just have to minus 1. Why is there a negative and then you're going to stop that? X squared. Okay, I did that. So no, I did it.
So basically, you just start off like x squared minus 1.
Wait, Miss, can you go back to the equation you did?
Your x is going to be different than x. Because it's going to get 3.
Minus.
Yo, be quiet. Be quiet. Shh. I need to tell you all something or you will mess up. Shh. Be quiet. Be quiet. My first announcement is that you really only have to do odds if you're not already done with 2 and 4. You could just do 1, 3, and 5. Okay? And we're gonna work on this again tomorrow. But you really want to try to figure it out today. 2 important things about number 3 and number 5 is that they need zeros. I have not done a 0 example with you yet. It is in the book. The one we went through had a 0, but listen, this should actually be written as x squared plus 0x minus 1. If you don't put a 0 in, it's not going to work. This one also needs a 0. It goes from x to the third to x to the first. You need to rewrite this with a 0x squared in there. That's on you. If you're overwhelmed and you hate math homework and you feel like it takes too long, just do what? If you feel like, I got this, I can figure this out in 10 minutes, then do all of them. Okay?
Oh, your grades get affected if you can't do all of them.
Oh, wait, no, never mind.
Yeah, it should be a 5.
I would.